Okay, so you guys, we are going to learn about compositions of isometries. And can I come in embedded in 9.4, we need to define isometry, so yay, we got that up there. We need to use translations, reflections, and rotations to describe how one figure can be made to match up with another, and name corresponding sides and angles that are congruent in a figure after transformation. And then in 9.5, we're going to understand two figures are congruent if and only if there's a sequence of rigid motions. Okay, so we're going to be looking for those four things as we go through the 9.4 information. So this is our first learning objective, is to be able to define isometry. It is a transformation that preserves distance or length.
What's the difference?
Between distance and length, or?
Yeah, distance and length. They're the same thing.
If it's a shape, you measure the distance. If I'm going somewhere, or measure the length. The difference is negligible. Both of them are equal. So if you have the same size from beginning to end, you have an isometry. Sam, can you read Theorem 9.1 for us?
The combination of two or more isometries.
Yeah, isometry. So even if you're doing two isometries, it's still, the combination is still an isometry. You're still getting the same size at the end of the transformation as when you started with. All right. You want to? Well, not right now. We're not there yet. We're on example 1. Dylan, can you read example 1 for me?
Of course. Which letters in the lowercase alphabet are transformations of each other? Name what type of transformation it is.
Okay, so we're looking at the lowercase alphabet, which is pretty interesting to me because usually we look at the uppercase alphabet when we're dealing with stuff.
Okay, I got one.
Okay, so Claire's got one. Which two are the same distance or length, just transformed? And what type of transformation is it? What do you think, Claire?
I think it's P and Q,
P?
and it's a rotation.
Wait, hold on. What type of transformation gives you P to Q?
Rotation.
Reflection.
Reflection?
Yeah, so if I had my mirror in between the two, and I reflected it, then I would get from P to Q.
Wait, you rotate it though? Like,
Rotated would be more of a B.
If I rotated
you
P,
go like all the way.
so watch this, if I rotate P, which I can do, no, what letter do you get? So we can do P and D
And then B.
using a rotation.
B and D are reflexive.
Rotation.
I don't know. No, I don't know.
Go ahead, Jesse.
N.
And then, so here's N. Reflection or rotation? Let's see. If we rotate N, do we get U? Heck yeah! So N and U.
I never thought of that.
And it's a rotation. Oh, that makes my N giant. Rotation. All right. Q and B. So let's look at our Q. And this is where my brain didn't go because I make my Q's with a little tail. And if you look, there is a Q without a tail here. So if we just have Q like this, and we oh, come on, buddy. We rotate him around, he is a B.
I got another one.
Rotation. That says rotation. For the record. Claire, give me another one.
Okay, so I know the W is pointy, but can we do W and M?
If we had a different shape W, we could. But in this case,
What
and
if
think
we
about
just
this.
Make
If it were an uppercase, we'd have a better
Yeah.
chance at making uppercase happen.
You can do Z.
Any others we're not seeing?
You can do Z.
B
and
and
D.
D is a reflection.
B and D is a reflection. Good job, guys.
Couldn't you do A and E
Whoa.
as a rotation?
I thought about that, but that is why.
And yeah, so the way it's written here, not.
You can do.
If you use a different font.
We could try that, but for our purposes, are you guys seeing how they're going to give you crazy scenarios like this, and we're going to have to really stretch our brains to find them. Okay, so Jacob, I promised you the pull tab here.
You can do N and Z.
If it were a different shape, it's like, remember when the guy had his little pens in his pocket, and we decided that wasn't a reflection because the pens didn't reflect to the other side.
Let's get.
Jay has the tail. We just put it on the bottom.
Like right here.
Hmm?
So it doesn't have no pens this on my burner.
No, I remember it was a topic.
No, there's no pens.
I'm recording. Yay. Okay, so a composition is a combination of transformations. A composition is a combination of transformations. So we have Chuck, did you read for me? So go ahead and read the example 2 instructions.
Why is there so many?
Pre-image of the dash image is your pre-image.
Okay, so we've got 3 figures. So there's 2 transformations happening, so it's a composition of transformations. The solid figure is the first one, the dashed figure is the second one, and the dot figure is the third one. So we're going to read these 3 instructions and see which one matches up with it. So the first transformation we do is rotation about point P. So if I start with this, our solid figure, rotating about point P would put it like somewhere over here. Start with this first figure, rotating about point P would be
Right there.
right there, or rotating about point P would be somewhere over here. So B is the only one that rotates first about this point P to get a dashed figure. So this one has to be B, and then just for fun, translate perpendicularly, which means that they just make a perpendicular line when you draw from point to point, across line N. All right, so 1 down, 2 to go. So then the next one we say translate parallel to line N. So we start with our figure, we translate parallel to line M. That is not going across, but moving it. Because remember, a translation just moves it. It's not a reflection. So it keeps the same. Okay, so this one moves it parallel to line M. So the number 2 is A. And then just for fun, reflect it across line M. So that leaves C as our last one. Reflect across line M, and then rotate counterclockwise around line P. So the answers to 1, 2, and 3 are B, A, C. Okay, this is super fun because you get to, those of you guys who are really good at drawing, you get to laugh at me during this time because I'm not super good at drawing. When we do a composition of transformations, it is noted the same way we do composition of functions. If I was in function notation, the open circle needs composition. Means I'm doing both of those actions to my original figure. You start from the inside out. So this guy goes first. The one closest to what you're acting on goes first. And then the outside one goes second. So I'm going to, and just FYI for the record, R is reflect, little r is rotate, and then T is translate. So we're going to reflect J across line L first. So I'm going to need the same distance between J and line L. And I just wrote in that area. Good job, Leah. So find about the same distance. You can do a finger pinch. For me, it's J to L. If you preserve that distance, it's right about here. Okay, so we're going to reflect it across line L first. And so this is the fun part, is trying to draw this reflection. So J was the little tail is to the left. Now our little tail has to be to the right. Because we're reflecting it. So it's like when you take a selfie, all you're writing on your shirt is backwards. So we're reflecting it across line L. And then we're going to reflect it across line M. So then I want to go back. I'm going to use a different color. So once again, I call this the finger pinch. I measure with my fingers the distance between the line and J. I'm going to reflect it again across, and it comes back because I'm reflecting this image. So reflecting it, it's now back to normal. How'd I do? Drawing. Give me a thumbs up if you're okay with crazy wiggly drawing. Okay.
Yeah.
So when you do composition, inside to outside. If you have a highlighter, go ahead and highlight this next sentence. Damien's going to read it out loud for us. A glide reflection.
A glide reflection is a composition of a reflection and a translation.
So I put together your midterm for you. We're going to take that right in a couple weeks. And it has a couple questions about glide reflections. This is why I'm having you highlight this, because there is a difference between a reflection and a glide reflection, and both of those on a multiple choice test are going to be an option. So I want you to know the difference. A glide reflection, it's got one extra word than the regular word reflection. So that means it's going to be a composition of a reflection and a translation. The translation is like the glide part. So think about this. We're just gliding it over and then reflecting. So we glide and reflect. That's a little dance move. A little Fred Astaire and Ginger Rogers beautiful dance move. So we're going to go ahead and do that with our text, T-E-X. So let's, Madeline, can you read example 4 for us while I'm plotting the points?
Find the following glide reflection. You want me to read the way?
Yeah.
R, X, U, T, 0, and then I. Triangle TX is the coordinates of the triangle. T negative 5, 2, E negative 1, 3, X.
Okay, my tendency, because I'm like, oh, that's graphing itself, is I hurry through my graphing part, and you guys have seen me completely biff graphing at easy coordinate. So please take your time on this. I'm going to use my line tool to make my triangle so it's actually a nice triangle. So we start out with TEX, and because we know it, we go from inside out, we're going to do this translation first. So this is our glide part in our glide reflection. We translate it 0 units on the X and -5 units on the Y. So essentially I'm moving all of my coordinates down 5. You can subtract 5 from each of these coordinates to find the new coordinate, or when you have a graph here, you can just move it 5 down, which is that's what I prefer because I'm a visual learner. So 1, 2, 3, 4, 5. Here's my T prime, and that's at -5 stays the same, and my Y becomes -3. Here's my X prime. It's -2, -4, and then my E becomes -1, -2. So we've just glided all the way down 5 units. Nice glide. Now the next thing we're going to do is we're going to reflect across the X, across X equals 0. So now we're here. X equals 0 is this line here. Remember, when we reflect, we preserve the distance. So E is closest. I'll do E first. He is 1 unit away. So my E double prime, because I'm going to put a prime and then a second prime to show that we've done 2 transformations or 2 operations on it, a composition of transformations, yeah. And it's going to be at 1, -2. So in this case, the Y stays the same, and the X just gets, the sign for the X gets changed. So this is 1, 2, 3, 4, 5 away from the X-axis. So our T prime prime is +5, -3. And then our X prime prime, we're 2 away. So the Y stays the same and the X becomes positive. And so my figure is this blue guy. Down here. Okay, so we're rolling right into 9-5. Thank you for hanging tight with me. Peter, go ahead and read. 2 figures are congruent if and only if. Okay, so remember we talked about rigid motion in the first section. Rigid motion means we're just moving it around and we're not making it bigger or making it smaller. Guess what we're going to do next block period? Make it bigger, make it smaller. So this is the last time we're going to keep objects rigid and not change their size. So this is our other learning objective for 9-5. If 2 figures are congruent, if and only if their transformations are rigid motions, and then we can map one onto the other. Okay, and then Clay, go ahead and read example 1. Okay. Which one is the easiest one to see that they're congruent? Because they're even oriented the same.
The parallelogram.
Parallelogram. So we can say find them.
Did you hide them?
I did hide them,
Whoa.
but I can't find it now that I've hidden them. Oh, it's mad at me. Come on, buddy. Too many clickings. Okay, so we can say
It's hungry.
that ADCB so I just went ADCB, that's the A, is congruent to parallelogram HKJI. And then it tells us how do we map one onto the other. And to do that, we're going to look at just one point. So I'm going to look at H and I. So I go from A to H by going to the right 1, 2, 3, 4, 5, 6 units. So it's a transformation. 6 units to the right. And 1, 2, 3, 4, 5 units down. So to go from ADCB to HKJI, I translate it 6 units to the right and 5 units down. Give me a thumbs up if that is a-okay for y'all. Thumbs up. The second one's going to be a little bit more difficult
Looks like a rotation.
because we have not a rotation but a reflection.
It is.
Yeah.
It looks like a
translation.
So we look at triangle VUW. VUW. It's congruent to NQM. And to get from VUW to NQM, we are going to translate down 6, or translate it to the left 6 units. So 1, 2, 3, 4, 6. So we move this guy 6 units this way. And then we reflect it across the x-axis. So when we reflect it, we get down here. This W that then becomes M, our V then becomes N, and our U becomes Q. So it is a reflection across the x-axis. So we translated 6 units to the left and reflect across the x-axis. Come on, little buddy. Okay. So if I had, we want to map NAV, which is this top right shape, onto BCW. So the first thing I would do is translate it 5 units to the left. And then reflect it across the x-axis.